Kia ora, Year 12. Here's the second part of question 7 from Stats 2, paper 71, May 2018. So this follows on from part 1 of the video, and you'll need to watch that first. This is a Poisson question, but in this part we're going to be doing some hypothesis testing with it. Okay, so go watch part 1 for the first part of the context. Now, this school teacher says that during football season there are more absences by boys than usual. And in part 1 we saw that we had per day a lambda of 0.3. So now we're looking at the number of absences by boys during a randomly chosen 5-day period. And the first thing we have to do is say, what's a type 1 error? Well, it makes sense to start thinking about our hypothesis test that's coming up in part B, which will have the null being that lambda is equal to 1.5, and the alternative, or H1, will have lambda, the absence rate, being greater than 1.5. So for part A, a type 1 error happens when we conclude that there are more absences than usual when there aren't. Okay, so conclude that something like this, mean rate of absences is greater than 1.5 per 5 days when it's not. Okay, so in other words, we're saying that we have got enough evidence to reject this when the null hypothesis is actually true. Okay, so on to part B. State the appropriate null and alternative hypotheses. Well, we've done that, and find the probability of a type 1 error. So to do that, when we're working with a discrete distribution like a binomial or a Poisson, we have to work out where our rejection region is. So that's what we're going to do now, and we're looking at a 5% significance level. So the easiest way to do this is to do your table of values and just figure out when we've hit our 5% threshold. So we found above that the probability of x being greater than 3 when mu equals 1.5 gave me a total of 0.0656. So 4, if we get 4 absences, that's not enough to reject. Okay, so probability of x being greater than 3 was just bigger than my significance level. So now we've got to say, well, what about the probability that x is greater than 4 when lambda is equal to 1.5? And if we go ahead and work that out, so that means that we're looking at the probability of 5 or more. Well, that works out to be 1 minus 0.934357, right? So that's coming from all of those values there, plus 0.047067. So that's just enough to tip me over the edge and give me the probability of a type 1 error being 0.0186. So hopefully that's clearer than mud. What we're saying is that if we have x greater than 4, that's when we're going to reject, and the chances that we're doing that incorrectly are 1.86%. Okay, so the probability of a type 1 error is equal to 0.0186. Remember that when you do this using a normal distribution or any other continuous one, you're never going to get this gap between your significance level and the type 1 error probability. It'll be the same thing. It's because we've got a jump from having a value up here that was just too high and here where we're quite a bit under our 5% number. All right. Now we're going to look at the last bit. We're actually going to do the hypothesis test now. So we're told, in fact, there were 4 absences by boys during this period. test the teacher's claim at the 5% level. So we've already done a lot of the legwork for this. Here's what we need to find. So probably that x is greater than or equal to 4, given that lambda is equal to 1.5. So we worked out that probability in part 1 of the video, and that is less than my significance level, so we don't reject. And we need to make a statement that answers that claim. So what it is that we've got no evidence at a 5% level of more than usual boys' absences. Thanks for watching. That's all the stats I'm going to do for a while. The next few days I'll be focusing on vectors. So if you've got vector questions from past papers that you want me to have a go at, email them through and I'll see what I can manage.